Hi, my name is Nur Afifah bin Zulkifli. So today our group will be presenting about two welding techniques, which are seam welding and atomic hydrogen arc welding. For my part, I will be explaining the introduction and working principle of seam welding. First of all, let me explain what is seam welding. So basically, seam welding is a type of resistance welding process where two metal sheets are joined together continuously using rotating wheel-shaped electrodes. In this process, the metal sheets are placed between two copper wheel electrodes. These electrodes rotate while applying pressure to the metal sheets. Seam welding is quite similar to spot welding, but there is one main difference. Spot welding produces separate weld points, while seam welding produces a continuous welded line along the joint. This continuous welded line is called a seam. Because of this continuous seam, the joint produced is very strong, airtight, and leak-proof. That is why seam welding is commonly used for products such as fuel tanks, steel drums, pipes, radiators, metal containers, and automotive parts. Now, I will explain the principle behind seam welding. Seam welding works based on electrical resistant heating. This means heat is produced when high electric current passes through the metal sheets. When the metal sheets are placed between the rotating wheel electrodes, pressure will be applied to hold the sheets together. This pressure is very important since it will make sure the surfaces are in close contact. Then, high electric current flows through the contact area between the metal sheets. Since the metal has some electrical resistances, the contact area will become hot. This heat will soften or melts the metal surfaces at the joint area. At the same time, pressure from the wheel electrodes helps the heated surface join together. The special part of seam welding is the rotating movement of the wheel electrodes. As the wheels rotate, the weld is not formed at only one point. Instead, the weld continues along the joint line. Because of this, as I said just now, seam welding can produce a continuous welded seam which is suitable for leak-proof and airtight joints. So in simple words, the principle of seam welding is based on pressure, electric current, heat from resistance, and rotating movement. So next, these are the main components used in seam welding. The first component is the wheel electrode. Wheel electrodes are usually made of copper because copper is a good conductor of electricity. These electrodes rotate continuously, apply pressure to the workpiece, and allow electric current to pass through the metal sheets. The second component is the transformer. The transformer supplies low voltage but very high current. High current is needed because seam welding requires enough heat to melt the metal surfaces at the joint area. And the third component is the control system. This control system controls important welding parameters such as welding current, welding speed, and electrode pressure. This is important because the quality of weld depends on the correct setting of this parameter. The fourth component is the cooling system, which is used to prevent the wheel electrodes from overheating during the welding process. The last component is the workpiece. The workpiece is the material that will be welded. In seam welding, the workpiece usually consists of thin metal sheets such as mild steel, stainless steel, or aluminium. This slide shows the step-by-step process of seam welding. The process starts by placing two metal sheets in the correct position between the upper and lower electrodes. After the sheets are positioned, the electrodes press them together to make sure the surfaces are in a close contact. Next, a high electric current will be supplied through the wheel electrodes and passes through the metal sheets. At the contact area, heat will be produced because of the resistance of the metal. This heat causes the surfaces of the metal sheets to become hot enough to join. While this is happening, the wheel electrodes keep rotating and moving along the joint line. As the wheels move, the weld is formed continuously instead of only at one point. The small weld spots overlap with each other and form one long continuous weld seam. Finally, the result is a very strong and sealed joint that is suitable for products that need to prevent leakage. So, the process flow can be summarized as position the metal sheets, secondly apply pressure, thirdly supply current, and fourth generate heat, rotate the electrodes, and form a continuous seam weld. This slide shows some examples of products that are commonly made using seam welding. Seam welding is widely used in industries to produce products that require strong, continuous, and leak-proof joints. For example, from this slide, seam welding is used in fuel tanks because fuel tanks must not leak fuel. It is also used in steel drums and metal containers because these products need to store liquids or materials safely. For pipes, seam welding helps prevent water or gas leakage. Meanwhile, for radiators, seam welding is very useful because radiators contain liquid and must be properly sealed. Seam welding is also used in automotive parts because it produces strong and durable joints. So from all of these examples, we can see that seam welding is very important in industries that need safe, reliable, and leak-proof metal joining.
Hello, my name is Nur Amna Hafizah binti Aziz, and now I will explain the advantage of seam welding. First, seam welding can produce continuous and strong weld because the welding joint is connected without gap. This gives more better weld strength and quality. The second advantage that I need to talk is about the process as high production speed, so it's more suitable for industry that need fast manufacturing and large production output. Besides that, what we can see is seam welding is suitable for mass production because the machine can operate continuously with constant welding quality. Another advantage is that the process is easy to automate because automatic machine can reduce manual work and improve production efficiency. Seam welding is also good for leak-proof joints, which are important for production such as tank, pipe, and container. Lastly, seam welding do not require filter materials, so it can reduce material cost and make the process more simple and cleaner. In the previous slide, I will talk about the advantage. Now I would like to talk about disadvantage. Seam welding also has several disadvantages. The first disadvantage that we can see is the equipment cost is high because the welding machine and installation system are expensive. The second, seam welding is limited to thin metal sheet, usually between 0.5 to 3 mm thickness. In addition, it's not only suitable for thick material because the heat is limited. Another disadvantage that we can see is the electrode wheel require regular maintenance since they wear out over the time during operation. Besides that, seam welding is less flexible for complex shape because it mainly used for straight or circular seam only. Lastly, seam welding has limited welding position and is commonly performed in a flat or horizontal position, which may restrict its use in some application only. This slide shows an industry application for seam welding using ACZFH 1500G straight stream welding machine. This machine fully automated and commonly used for pipe and ducting welding in industry. It offers high welding speed and good precision and also improve production efficiency for industry application.
The straight seam welding machine can weld material with diameters ranging from 100 to 5,600 mm and lengths ranging from 100 to 5,500 mm welding stroke. It can weld a wide range of materials, including SUS, carbon steel, galvanized sheet, and stainless steel, with thicknesses ranging from 0.63 mm. Welding speeds vary depending on the thickness of the material. TAG welding speeds can reach 15 mm/s, while MIG welding speeds are 15 mm/s. Laser welding speeds are even faster, and repeatability can reach 0.1 mm. The straight seam welding machine is primarily used for axial fan ducting and ventilation applications. It can weld even heavy pipes. Its user-friendly interface reduces learning curves and training costs. The machine's vertical lift function and feed roller support enable fully automated production, significantly improving production efficiency and quality. After the axial fan duct is rolled, the welding machine can be used to weld the materials. Therefore, the straight seam welding machine can be combined with a rolling machine and a conveyor belt in the production line to achieve full line automation.
This slide shows several communication applications for seam welding in industry manufacturing. First, seam welding is widely used in full time because it can produce strong and leak-proof joints. It also used in automatic body parts to ensure continuous and durable welding connection. Besides that, seam welding is suitable for manufacturing metal drum and container, especially products that require airtight sealing. The process is also commonly applied in pipe and tube production because it provides smooth and continuous weld seam. Lastly, what we can see is seam welding is used for airtight container in industry that requires safe storage of liquid or gases. In conclusion, sea welding is fast and reliable welding process that produces strong and continuous weld joints. Due to its high efficiency and ability to support automation, it is widely used in industry manufacturing applications such as pipe, fuel tank, and other systems.
Hello everyone, my name is Muhammad Amirul Faiz. Now we will move on to the second topic, which is atomic hydrogen arc welding. To begin, let's look at the basic definition of this technique. Atomic hydrogen arc welding is a very unique thermochemical arc welding process. In this method, two metal pieces are joined together by utilizing the intense heat generated from an alternating current electric arc. This electric arc is maintained strictly between two tungsten electrodes, and it is surrounded by a continuous stream of hydrogen gas. Unlike other welding processes, this technique relies heavily on three main core elements. First, it uses chemical recombination heat to melt the metal. Second, it utilizes the hydrogen gas itself to provide complete atmospheric shielding. And third, it operates using an independent electric arc that does not touch the workpiece directly. Now, let us understand the underlying scientific principle of operation behind this process, which can be broken down into six clean steps. First, an electric arc is struck and maintained continuously between two inclined tungsten electrodes. Second, a controlled stream of molecular hydrogen gas is passed directly through this intense arc stream. Third, due to the extreme heat of the arc, which can reach up to 40,000 degrees Celsius, the molecular hydrogen gas absorbs a massive amount of energy and breaks apart or dissociates into single hydrogen atoms. This is a highly endothermic reaction. Fourth, these highly unstable single atoms are pushed out of the touch and hit the relatively cooler workpiece surface. Fifth, as soon as they touch the metal, these single atoms instantly recombine back into standard stable molecules. Because this recombination is an exothermic reaction, a massive amount of stored thermal energy is released directly into the joint area, hitting temperatures around 3750 degrees Celsius. Finally, in step 6, this extreme chemical heat rapidly melts the metal surface to create a clean, high quality wet pool. Now, let us look at the five main technical components required to safely execute this atomic hydrogen process in modern industries. Component number one is the welding torch. This specialized torch holds the two inclined tungsten electrodes at a precise angle and carefully directs the stream of hydrogen gas straight into the arc zone. Component number two is the transformer. This is an AC power source that transforms our grid voltage into the correct adjustable electrical current needed to strike and maintain the arc evenly across both tungsten tips. Component number three is the gas cylinder, which stores the high pressure hydrogen gas and supplies it through a regulator to continuously protect and heat the web. Component number four is the stepper motor. We chose to highlight this automated electronic motor because in modern automated system, it is used to precisely adjust and fine-tune the gap distance between the electrode tips without manual errors. Finally, component number five is the workpiece. These are the base metal parts being joined, which in the case of this high temperature technique are usually thick steel plates or hard to weld refractory metals like tungsten or molybdenum. Now, let us look at the complete step-by-step process flow that an automated system follows during the welding operation. First, in step 1, the hydrogen gas supply is turned on to purge the lines and establish the protective gas flow. Second, in step 2, the AC power is activated and the electric arc is struck between the two tungsten electrodes. Third, in step 3, the molecular hydrogen gas begins to pass through this newly formed high temperature arc zone. Next, in step 4, the intense thermal energy forces the molecules to dissociate into single atomic hydrogen. In step 5, these traveling hydrogen atoms hit the metal joint and recombine back into molecules on the workpiece surface. Finally, in step 6, the intense exothermic heat release from this chemical recombination instantly forms a perfectly molten wet pool to fuse the thick plates together.
Hello, I'm Irfan. Atomic hydrogen arc welding has several important advantages that make it unique compared to the other welding methods. First, it can achieve an extremely high temperature of around 3,500 to 4,000 degrees Celsius. It allows it to weld very high melting point metals such as tungsten and molybdenum. Second, the arc is very stable and controllable because it burns between two tungsten electrodes instead of directly on workpiece. This gives better precision during welding. Another advantage is the hydrogen ratio. Hydrogen protects the weld area from the oxidation and contamination, producing cleaner and higher quality welds. Atomic hydrogen arc welding is also suitable for difficult metals and special alloys that require a very clean environment. In addition, no flux is needed, so there's less contamination and less cleaning after welding. Lastly, hydrogen recombination release additional heat energy which improve thermal efficiency. Despite its advantages, atomic hydrogen arc welding also has several major disadvantages. The first issue is high operating costs. It requires hydrogen gas supply and specialized equipment, making it more expensive than MIG or TIG welding. Second is hydrogen embrittlement. Hydrogen can enter certain metals and make them brittle, which may lead to cracks or structural failure over time. Another major concern is safety. Hydrogen gas is highly flammable and explosive, so strict ventilation and safety systems are necessary. Atomic hydrogen arc welding is also difficult to automate because it is mainly a manual welding process. This reduces production speed in industries. In modern industries, atomic hydrogen arc welding has mostly been replaced by TIG welding, which provides similar weld quality with safe operation and lower costs. Finally, it requires highly skilled operators because controlling the arc between two electrodes is more complex. When comparing atomic hydrogen arc welding with MIG and TIG welding, you can clearly see why it became less popular. Atomic hydrogen arc welding use hydrogen shielding, while MIG and TIG use inert gases such as argon or helium. Atomic hydrogen arc welding provides very high weld quality and extremely high temperature, but the process is slow and expensive. MIG welding is much safer and easier to automate, making it more suitable for mass industrial production. TIG welding offers excellent precision and quality with better safety and easier control compared to atomic hydrogen arc welding. Because of these advantages, TIG and MIG gradually replaced atomic hydrogen arc welding in most industries. Although atomic hydrogen arc welding is mostly obsolete, it has not completely disappeared. One reason is its unique self-shielding property using hydrogen, which can still be useful in certain field conditions. Its extremely high temperature is also useful for refractory metals like tungsten that are difficult to weld using normal methods. Some research laboratories and older industrial plants still use atomic hydrogen arc welding equipment for specialized applications. However, modern TIG systems are safer, smaller, cheaper, and easier to automate, which is why they dominate today's industries. Atomic hydrogen arc welding is mainly used in specialized industrial applications. In aerospace and defense industries, it is used for welding tungsten and molybdenum components, rocket nozzles, and heat-resistant structures. In tool and die manufacturing, it is used to repair high-speed steel tools and rebuild worn surfaces. Research laboratories also use atomic hydrogen arc welding for experimental metals and advanced alloy prototype fabrication. In stainless steel fabrication, it is used for precision welding in chemical plants, food-grade equipment, and pharmaceutical industries, where clean weld quality is important. This application shows that atomic hydrogen arc welding is still valuable for niche and high-performance welding tasks. In conclusion, atomic hydrogen arc welding was an important development in welding technology and became the pioneer of hydrogen-shielded arc welding. Its extremely high temperature and clean weld quality make it suitable for difficult and refractory metals. However, high cost, hydrogen safety risks, slow speed, and difficult operation limited its widespread industrial use. Today, TIG welding has become the main replacement because it offers similar quality with better safety, speed, and automation. Even so, Atomic hydrogen arc welding still remains relevant in specialized research and niche industrial applications. That's all from us. Thank you.